This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Services. In this presentation, we're going to learn how to identify parallel and perpendicular lines. You'll be able to write an equation of a line that is parallel or perpendicular to the graph of a given equation and that passes through a given point. Some questions. What determines if a slope is parallel or perpendicular? What does the term opposite reciprocal mean? What do parallel and perpendicular lines look like when graphed? What do parallel and perpendicular lines look like in slope-intercept form? And can I tell if lines are parallel or perpendicular when the equations are in standard form? Here's an example of some parallel lines. Each line has a specific equation. The black line is y equals 1x plus 4. The red line, y equals 1x plus 3 over 2, and so on. What you'll notice is that all of the m's are the same. When your m's are the same, lines are parallel. Notice that when they cross each other, in order for them to be truly perpendicular, they have to cross at a 90-degree angle or form a 90-degree angle. We're talking about opposite reciprocal slopes. The black line, the m is positive 2 over 1, and in the red line, the m is a negative 1 over 2. These would be perpendicular lines. We've got two equations, and we need to determine if they're parallel or perpendicular or neither. Notice that the m's are different and the y-intercepts are the same. When we set the x equal to 0 in both equations, the b equals 1. That's my y-intercept. So I can plot these points together. There's my b for my blue line, and here's the y-intercept for the red. Now, because these slopes are different, we know that they're going to have different angles, and they're going to run in different directions because this is a negative and this is a positive. So let's find out the second point. For the blue line, I'm going to replace my x with a positive 2. That will cancel this out, and I'm left with y is equal to negative 3 plus 1, which is negative 2. When x is a 2, my y is a negative 2. So I plot that point at 2, negative 2. And I'm going to do the same thing for the red line. In this case, I'm going to substitute the x with a 1 because that's the denominator in this particular problem. These cancel out, and I'm left with y is equal to 2 plus 1, or y is equal to 3. When x is 1, y is 3. 1, 3. And I can go ahead and graph both these lines. In this situation, these two equations, this would be a neither. And it would be a neither for the simple fact that the slopes are not the same, but they're also not opposite reciprocals of each other. We've got three equations here that we need to graph and figure out if they're parallel, perpendicular, or neither. My y-intercept for the black line is positive 2. And when I replace the x with 5, I'm left with 3 plus 2 is 5, so 5. My red line crosses the y at a negative 1. When I replace my x with 3, I'm left with negative 5 minus 1, which is a negative 6. So 3 comma negative 6. And with my green line, My y-intercept is a negative 4. When I replace my x with 5, 3 minus 4 is a negative 1. So we're left with 5, negative 1. And now I can go ahead and graph all of these. The green line and the black line are parallel to each other. Notice that they'll never cross. And additionally, the slopes are the same. The red line is perpendicular to both the green and the black because it's an opposite, meaning it's a negative instead of a positive, and it's the reciprocal of each other, meaning the number is flipped upside down. I have an equation. My directions are to write an equation of a line in slope-intercept form that is parallel to the given line and runs through the given point. Here's my given line. Here's my given points. I'm going to go ahead and graph 4x plus 5. There's my positive 5. From that point, I'm going to go down 4 to the left 1. And I've got a point, 2, negative 3. And I know that that line is going to be parallel to this, so it's got to have the same slope. So I'm going to use the equation, the point slope form equation. Y minus y1 equals m parentheses x minus x1. And I'm going to plug in these values into my y1 and x1. Y minus a negative 3 becomes a positive 3. My m is 4. And I know my m is 4 because it has to be parallel, which means that the slopes are the same. Minus a 2. And I simplify this. Y plus 3 equals 4x minus 8. I subtract my 3 to get y by itself. And my y-intercept is at a positive 4. And my y-intercept is at a negative 11. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll just have that. And there's my line.